For centuries, humanity has looked up at the stars and wondered if we are truly alone in the cosmos. We dreamed of finding other worlds, planets orbiting distant suns that might harbor the ingredients for life. But for a long time, these distant alien worlds remained hidden in the deep shadows of space. To find them, we needed a revolutionary new tool, a telescope designed specifically to hunt for planets. That tool was the Kepler Space Telescope, a spacecraft built for one single, historic mission. Its purpose was to stare continuously at a single, specific patch of our Milky Way galaxy. By focusing on this one region, Kepler would search for the tiny signatures of distant exoplanets. This dedicated exoplanet hunter would observe hundreds of thousands of stars simultaneously, watching for changes. It watched for the slightest dip in starlight, a clue that a planet was passing in front. During its historic lifetime, Kepler would discover thousands of these fascinating, distant alien worlds. The journey began in 2009, when Kepler was launched as part of NASA's Discovery program. With a powerful roar, the rocket lifted off, carrying humanity's greatest planet hunter into the heavens. It climbed higher and higher, leaving Earth's atmosphere behind to begin its silent vigil in space. Once in orbit, Kepler separated from its booster, ready to open its eyes to the cosmos. It entered an orbit trailing behind Earth, far away from the light pollution of our home planet. At the time of its launch, Kepler possessed the largest primary mirror ever sent into space. This powerful mirror was designed to gather as much light as possible from faint, distant stars. The gathered light was directed onto an incredibly advanced, highly sensitive camera system. This massive 96-megapixel camera was the largest ever flown in space at that time. It allowed astronomers to measure the brightness of over 100,000 stars with incredible precision. Astronomers were eager to answer fundamental questions about the nature of planetary systems in our galaxy.
They wanted to know how many stars host planets, and what those planets are actually like.
Kepler's mission was to provide the statistical data needed to understand the abundance of alien worlds. Over its 9 years in space, Kepler would observe over 500,000 stars in detail. It monitored stars of all sizes and temperatures, searching for any sign of orbiting planets. The results were staggering, revealing a galaxy teeming with an incredible variety of exoplanets. Kepler confirmed the existence of thousands of new worlds, forever changing our view of the universe. It found planets where we never expected them, in orbits that challenged our theories of planet formation.
By the end of its mission, Kepler had confirmed over 2,600 new exoplanets.
These discoveries proved that planets are incredibly common, perhaps outnumbering the stars in our galaxy.
Many of these newly discovered worlds are unlike anything we have ever seen in our solar system. Some are extreme worlds, with temperatures hot enough to melt iron and vaporize rock.
These scorched planets orbit so close to their stars that their years last only a few hours.
They are constantly bombarded by intense radiation, stripping away their atmospheres and leaving barren rock. One hemisphere is locked in perpetual daylight, a molten wasteland of liquid rock and fire. Other exoplanets orbit binary star systems, worlds with two suns shining in their skies. If you stood on the surface of one of these planets, you would cast two shadows. You would witness a spectacular double sunset, a scene straight out of science fiction made real. The two suns paint the sky in vibrant shades of orange, red, and deep purple. These binary systems show us just how diverse and surprising the universe can be.
But the ultimate goal of Kepler was to find planets in the habitable zone of their stars.
This is the region where temperatures are just right for liquid water to exist on a planet's surface. Water is the essential ingredient for life as we know it, the key to habitability. In this Goldilocks zone, a planet is neither too hot nor too cold to support life. Kepler's legacy is that it successfully found Earth-sized worlds orbiting within these habitable zones. One of the most exciting habitable zone planets discovered is a world known as K2-18b. Located 124 light-years away, K2-18b is significantly larger than Earth. It has about 8 times the mass of Earth and is 3 times as big. In September 2019, K2-18b made headlines around the world for a historic discovery. 2 independent scientific teams announced they had found signs of water vapor in its atmosphere. This was the first time water had been detected on a habitable zone exoplanet. The discovery of water vapor suggested that K2-18b could potentially support liquid oceans. It was a landmark moment in the search for life beyond our solar system.
The finding ignited excitement among researchers and the public alike, offering a glimpse of habitability.
But K2-18b orbits a very different kind of star than our own Sun.
Its host star, K2-18, is a red dwarf, the most common type of star.
Red dwarfs are smaller and cooler than our Sun, but they are incredibly long-lived.
Because they are so common, they represent our best chance of finding habitable worlds.
However, these red stars can be highly active, emitting powerful flares of energy. This radiation poses a significant challenge to the survival of life on nearby planets. To detect these planets, Kepler relied on a technique known as the transit method. As a planet passes in front of its star, it blocks a tiny amount of light.
By measuring this tiny dip in brightness, astronomers can confirm the planet's existence.
The depth of the dip reveals the size of the planet relative to its star. And the time between transits tells us how long it takes to complete one orbit.
But detecting these transits is an incredibly difficult and delicate task.
An Earth-sized planet blocking a Sun-like star causes only a tiny change in light.
It dims the star's light by a mere fraction of a percent, almost imperceptible.
But detecting these transits is an incredibly difficult and delicate task.
It required unprecedented precision, a triumph of modern engineering and scientific dedication.
In 2014, Kepler made another historic discovery with a planet called Kepler-186f.
This was the first Earth-sized planet found in the habitable zone of another star. A recent study suggests that Kepler-186f has a stable axial tilt, like Earth. This stable tilt means the planet likely experiences regular, predictable seasonal cycles. It could have a stable climate, making it a prime candidate for hosting life. Another fascinating world discovered in Kepler's archive data is Kepler-11649c. This planet is incredibly similar to Earth in both size and estimated temperature. It receives about 75% of the light that Earth receives from our Sun. This means its surface temperature could be very close to that of our home planet. It is one of the most promising Earth-like worlds ever found by Kepler. But out of thousands of discovered exoplanets, only a small fraction are truly habitable. Only about 16 of Kepler's discoveries lie within the Goldilocks zone of their stars. Many of these planets face extreme challenges, such as being tidally locked to their stars. This means one side is always burning, while the other is frozen in darkness. Others are mini-Neptunes, planets with thick hydrogen atmospheres that crush any hope of life. The intense pressure and heat beneath these gas layers make life as we know it impossible. And active red dwarf stars can strip away a planet's atmosphere with violent flares.
Without an atmosphere, liquid water cannot exist, leaving the planet dry and barren. These harsh conditions make the search for truly habitable worlds a complex challenge.
Temperatures can range from freezing cold to boiling hot, depending on the planet's atmosphere.
Yet, statistical analysis of Kepler's data offers an incredibly hopeful conclusion. Astronomers estimate that 1 in 5 Sun-like stars has an Earth-sized planet in its habitable zone.
This means there could be billions of potentially habitable worlds in our galaxy alone. The sheer scale of these numbers suggests that life could be common in the universe. Kepler has shown us that our galaxy is filled with possibilities, waiting to be explored. But Kepler also discovered many non-habitable worlds that are fascinating in their own right. It found hot Jupiters, massive gas giants orbiting extremely close to their parent stars. One such world is KOI 5AB, a planet orbiting within a complex 3-star system.
This unique system challenged our understanding of how planets form in multi-star environments.
Kepler also discovered super-Earths, rocky planets larger than Earth but smaller than Neptune.
In October 2018, Kepler's historic mission finally came to an end as it ran out of fuel.
NASA sent a final goodnight command, permanently deactivating the telescope and leaving it to drift. It remains in a silent orbit around the Sun, a monument to humanity's curiosity. Now, new telescopes like James Webb are carrying on Kepler's legacy, looking even closer and bringing us closer to answering the ultimate question: are we alone in the universe?